All right, so we're going to learn lesson 6.3, solving linear systems by adding or subtracting. Remember, when you're solving a linear system, essentially, you're thinking about two lines, linear, that cross somewhere, and at the point at where they meet is the answer. So solving linear systems is always going to produce an x and y as your answer. The only other two possibilities, this would be the one solution answer. One solution. The other possibilities is no solution. And that's when you have two lines that are parallel, so they never cross. Write this down. And the third option would be infinitely many solutions. And that's when you have a line, and then you have the exact same line again. So it's a line on top of a line. So we're going to use the elimination method. You learned a substitution method on the last lesson. So elimination method, which is the key concept you should have already written down. So when you're doing the elimination method, let's look at example 1. We have two equations. We have 2x plus 3y equals 11. And then we have negative 2x plus 5y equals 13. With elimination method, you're going to look at these two equations. You're going to line up the variables, which in this case they've already done for us. See how the x's line up, the y's line up, and then the number by itself lines up. And you're going to see if you can eliminate one of the variables, hence the name elimination. So in this case, we have a positive 2x and a negative 2x. If I add those together, does that get rid of the x altogether?
Yes.
Yes, because one's positive, one's negative. So essentially, I'm going to go add this going down. So 2x minus 2x is just gone, so that cancels. So then I have 5 plus 3, which is 8y equals, and then 13 plus 11, which is 24. So I've eliminated the x. Now I can just solve for y. So how do I get y by itself?
Divide by 8.
Yep, divide both sides by 8. Keep writing. What's 24 divided by 8?
24 divided by 4?
Nope.
3.
3. Okay, so now we know my y value is 3. Then all you have to do is grab that 3 and plug it into one of the original equations wherever the y is. I like messing with just positive numbers, so I'm going to put it in this top equation. So that goes where the y is. So I'm going to say 2x plus 3, substitute my answer, which is 3 for y, equals 11. And now we just solve for x. So I have 2x plus, what's 3 times 3?
9.
Yep. Now to solve for x, I have to move the 9. So I'm left with 2x equals, what's 11 minus 9? 2. And then the last step is to divide 2 away. And I get x equals 1. So then the answer to this system of linear equations is going to be 1, 3, because you always write it like a point. So I have one solution to this system of linear equations, and it's at 1, 3. So if I were to graph these two lines, they would cross at the point 1, 3. Make sense?
Yeah.
All right, everybody got this?
Yes.
Good. All right, so let's look at example 2. So now we're going to look at another set and use subtraction. What we did in the last one was addition. Now we can use subtraction. So if I have 4x plus 3y equals 2, and then I have 5x plus 3y equals negative 2. So in this case, I look at my variables, and can I subtract out something and cancel out?
Yes.
These have the same coefficient. So if I subtract, my y's are going to be gone, right?
Yes.
All right. So 4 minus 5 is what?
Negative 1.
Negative 1. So I just say negative x or negative 1x. The 3's are gone. What is 2 minus a negative 2?
0.
2 minus a negative 2.
Oh, negative 1.
So think about it, 2 minus a negative 2. These next to each other make it 2 plus 2. So it's actually 4. This is where the little things can trip you up, so pay attention. Okay, because this whole thing, I'm subtracting this whole equation. So 2 minus a negative 2, when I have a negative and a negative, it becomes a positive. All right, so now I almost have x by itself, right? I just have that negative in front of it. Can't leave a variable with a negative, so you're going to divide everything by a negative 1. So then I get x equals negative 4. So now I've solved for my x variable. Good so far? Yes. Okay, so now I'm going to plug that 4 into the y in one of these equations. And again, I like messing with positive numbers, so I'm going to use the top equation. So I have 4, open parenthesis, plug in the x value that I got, plus 3y equals 2. 4 times the negative 4 is negative 16. And then to move the 16, I just add it. I get 3y equals 18. Divide by 3. Divide by 3. What is 18 divided by 3? 6, right? 6 times 3 is 18. So now I have my y value, and I can write my final answer as my point. 4 comma, negative 4 comma 6. Not negative 6. Positive 6. So again, I have one solution, and it's at the point negative 4 comma 6. Not too bad, right? Yes, no? All right. Let's look at example. We're getting a little trickier just to make sure you're paying attention. So I have 8x minus 4y equals negative 4, and then 4y equals 3x plus 14. What is my first step here? Anybody have a guess? No? Are my variables lined up with their coefficients? No, this has got x and y together. This is on the other side of the equal sign. So I need to rearrange one of the equations so that way that's x plus y equals a number, or minus y. So y is already on the left. So if I move this 3x over here, I get negative 3x plus 4y equals 14 for this second equation, right? All I did was move this 3x over here. Now I have my x and y on the left-hand side and my number on the right-hand side. So now I can add it to this top equation. So I'm just going to write it lined up like so. Now, can I combine these to cancel out one of my variables? Do I need to do anything else to it? No, because look at the 4s. One's positive and one's negative. We can easily just add. Okay, so 8 minus 3 is 5x. Those cancel. 14 minus 4 would be 10. And then I divide by 5 on both sides, and I get x equals what? 2. So now you just grab that 2 and plug it into one of the original equations. It doesn't really matter which one. I can even plug it into this one that was not arranged how I wanted it. I could say 4y equals 3 times my x plus 14. So 4y equals 6 plus 14. What's 6 plus 14? 20. And then divide by 4. So y equals 5. So then my answer is going to be 2 comma 5. Again, one solution. So yay. So far, so good? Making sense?
Yes.
So you got to line up your x's and y's and the other side of the equal sign, and then you add going down. You can subtract going down. I always recommend you try and make it to where you can add going down. The math is easier in your head. All right, do you want to do any more examples? That's the lesson. But I could do another example or two if you want. Okay, so I'm going to look at the bottom of page 387. and do a couple of those. So let's look at, this is number 1 down there. 4x minus 3y equals 5. Negative 2x plus 3y equals negative 7. So first thing I need to look, is there either one of these variables set up for me to eliminate?
The x's.
The y's are.
The y.
Yep, because one's a positive 3, one's a negative 3. Okay, so those are already canceled. What's 4 minus 2?
2.
And then what's negative 7 plus 5? It's negative
Negative 7.
2.
Negative 2.
So then I divide by 2. X equals negative 1, right?
Yeah.
So now I plug that into one of these. Doesn't matter which one. I'm just going to pick the top one. So I have 4 times negative 1 minus 3y equals 5. What's 4 times negative 1? Negative 4. So then to move the 4, I'm going to add, plus 4, plus 4. So I get negative 3 equals, what's 5 plus 4? 9. Then I divide by my negative 3. It'd be what?
It'd be 3.
Negative 3, right? Because it's a negative 3 on the bottom. So then my answer is going to be negative 1 comma negative 3. Make sure you finalize and put it in this form. That's the proper way to write it. Good?
Yeah.
All right, let me do one more example. Got it?
Yeah.
All right, I'm going to put 5 on here, just for practice. So I have 3x plus 4y equals negative 6, and then I have 2y equals 3x plus 6. What's the first thing I need to do?
Arrange them.
Rearrange it. Very good. So I'm going to grab this 3x and move it over here by subtracting. So minus 3x minus 3x. So my new equation would be negative 3x plus 2y equals 6. And then I'm just going to rewrite that top equation. 3x plus 4y equals negative 6. This works out. Because if you look, my x's can cancel. I have a negative 3 and a positive 3, so they just cancel. So they're gone. What's 4 plus 2?
4 plus 2 equals 6.
A negative 6 plus a 6
That'd be 0.
would be 0. So divide by 6, divide by 6. What is 0 divided by 6?
0.
It's still 0. So that's my y value. Now I'm going to plug it into one of the originals. It does not matter which one, so I'm going to pick the top one. I have 3x plus 4 times 0 equals negative 6. 4 times 0 is just 0, right?
Yeah.
So then I get 3x equals negative 6. Divide by 3, and I get x equals what? Negative 2. So then write it as your final answer. Negative 2 comma 0. Any questions? Feel like you understand elimination method?
Yeah.
My 8th graders are in love with this right now. This is their favorite method of solving for systems. I like substitution better, the last lesson y'all did, but it's a preference. All right.
Theirs is not as hard as this, right?
Yeah, it's the same thing.
It's the same thing.
Like they literally could do this right now. Yep. Like algebra repeats and rebuilds. So you're getting the repeat and then we're going to build to it. All right, so doing numbers, 3 through 35, but just the odds. This is lesson 6.3.